Great. All right. Well, welcome everybody. Good morning or good afternoon, depending on which time zone you're in currently. It's still morning here at Montana State University in Bozeman. My name is Susie Taylor. I'm part of the NEBP education team, and it is my pleasure to welcome you to the NEBP speaker series. We are recording today's presentation. We have a lot of students who are in class, and this will enable them to take part in the presentation later. So thanks everybody for being here today. Our guest today is Dr. Sarah Roth. She's the Chief Technologist with the NASA Balloon Program Office at the Wallops Flight Facility in Virginia. In just a moment, you'll be hearing from Dr. Roth and about the work that she does with NASA. I do just want to remind everybody, if you're new to the NEBP speaker series, we are hosting speakers pretty much every week and sometimes even 2 in a week from now until the next eclipse in April. So we do hope you look out for those announcements. We do record all of the presentations. If you can't be with us live, you can definitely come back and watch those. And I wanted to give a quick announcement that the Nationwide Eclipse Ballooning Project is supported by NASA's Science Mission Directorate SciAct program, as well as the NASA Space Grant College and Fellowship program. And again, if you're new to the series, our goal with the series is really to help you, the members of the NEBP community, to meet professionals from NASA, other people in STEM fields, and just really broaden your network and learn about all the various pathways that are out there for you, and hopefully meet some great new people out there who are part of the community. All right, with that, I'm going to turn it over to Dr. Roth. We will have time for questions at the end, but it sounds like you can also type any questions in the chat as we go along, and we will help facilitate those and pass them on to Dr. Roth.
Thanks for that intro. I definitely want to encourage questions. I love interaction, so I don't want to be just talking the whole time. I'm going to give you guys a basic overview of what the NASA Balloon Program is doing and what our capabilities are, but I also wanted to tell you a little bit about, I guess, just myself and my STEM journey. And I'll start with the fact that I am home today with COVID and with a COVID positive toddler. So if you want a real life, this is how we do work and parenting at the same time, you're going to get it today. So I'll apologize if you hear craziness in the background, or if I have to lunge over to the side to deliver more ramen noodles, because that's the only thing she will eat. Although for most of you being college students, I guess maybe you're okay with that. I know it's been a while since I was in college. I remember eating a lot of ramen. So that, I guess, let's talk about my STEM journey, because you're going to find this pretty crazy. I encourage questions, even if that's like unmute yourself and interrupt me. I'm totally okay with that. I actually got my bachelor's degree in music education, and I was a band director for several years. Life is crazy and things happen. And, there's recession and budget cuts and whatever. I stopped teaching. I joined the Navy because I needed to learn some new life skills, and I needed someone else to pay for it. So the military is fantastic for that kind of thing. And when I got out, I decided to go back to school for engineering. So then I got a master's in chemical engineering. And then I did an internship with NASA, and I really liked it. I liked the difference between doing like research for the sake of research. So with government labs and academia are really similar in that respect, versus like working for a commercial company. So I did some internships with commercial companies too. And the environment, the pace is different. Now I'll tell you, the resources are also very different. So I went from, this nice commercial lab with shiny equipment to a government lab where we make a lot of our stuff out of duct tape and plywood. And you're thinking, oh, wow, NASA, it should be amazing. No. I'm going to tell you about our program here, and you're going to be shocked at what we can do with a shoestring budget. This is why I love ballooning. And you're probably already experiencing this with your teams, is that you can do amazing work amazing science with very little, right? As long as you're really persistent and you're thoughtful on how you set things up. And it turns out that ballooning, at least in the US, has been that way since the 50s. Great science with a shoestring budget. And they used to, it's weird, they used to call them like balloon cowboys or something like that, because our facility is out in Texas. The Columbia Scientific Balloon Facility is NASA's primary operations contractor. All the main payload integrations happen out there. We do some launches out there. But that facility was set up in the 60s as a way to help the entire United States scientific balloon community get some cohesiveness in how they operate, like how they actually launch balloons. So they wanted to get more consistent flights, more consistent results. And by setting up this organization, they did that because they concentrated all the knowledge. So those guys have been operating down there forever. And, they are cowboys because, yes, they're from Texas. They're also cowboys because they just kind of make things happen and then apologize later if they have to. And it's incredible, the work that they're able to do. And then, since you keep hearing me say things like we and they, and so yes, they are part of the NASA program, but over in Wallops, we're really doing most of the mission management and the technology development, new technology developments. We're at CSBF, that's where they're doing most of the operations. So let me dive into, I guess, what the program is doing here. And again, I encourage you to just shout out if you got a question. Everybody see the main screen? You guys see the big balloon on there?
Yep, we've got it.
Okay, it's like somebody grunt if you can hear me.
We can hear you, Sarah.
Okay. So I did mention, right, shoestring budget, right? We are probably the lowest cost way to get to near space. So we're flying between 90 and 150,000 feet generally. So it is definitely well within Earth's atmosphere where you can't do microgravity type experiments, but we're above 99.9% of the atmosphere. So it is a phenomenal place for things like astrophysics, things that need to be far enough outside of atmospheric disturbances to get good, clear pictures. Since we recover these payloads, they're reusable. Since we are not putting things all the way into space, we really keep the cost down. We're also a really, really quick turnaround. So we can get from proposal to flight in 6 months if need be. So it's really unique among the NASA programs for that kind of response. So we do have two different types of balloons. So for both of our balloons, they're designed to fly at a particular pressure altitude. So they're not going to go up and then overpressurize and pop. So the volume is designed to contain the gas at a specific altitude and fly for as long as possible. So the zero pressure balloon is really our workhorse. It's the same type of balloon since the 50s. And it has vents in the bottom of the balloon. And so it'll actually vent to any excess helium to prevent overpressurization. And then at night, when we start to lose altitude, we'll end up dropping ballast just to maintain a minimum altitude for science. Our super pressure balloon, though, is completely closed. And it is designed with a little bit of give to it, so it can kind of stretch a little bit day to night, but it can maintain a really stable pressure altitude. And usually it's like a delta of less than 200 feet, 200 meters. Sorry, this graph is 200 meters day to night in a GPS altitude. Yeah, so we can carry up to 8,000 pounds suspended mass. In order to do that up to 120,000 feet, we actually need extremely large volume balloons. So you can actually fit an entire football field inside of the balloon when it's fully inflated. when you're going to see the launch video here, when the balloon is standing up right before launch, you know, most of the balloon doesn't contain any gas because we want that gas to be able to expand at altitude. But you'll see it's significantly taller than the Washington Monument. And even when it reaches its full shape at float, it's still taller than the monument. We need to get that payload far enough away from the balloon that there's a good line of sight around it for whatever science target it has. The entire balloon is made by hand. So we are using linear low density polyethylene. That's the same material as your saran wrap and Ziploc bags. And then it's just laid out sheet by sheet and then basically melted together to form these gores, kind of like a beach ball in shape. And then they box it up and, you know, we ship it out to the facility. So it's an amazing process. It takes several months to make a balloon, a lot of hands-on, a lot of really intense quality control from some really great people. So I mentioned a couple different volumes here, and we try to provide enough different balloon sizes so that we can maximize our capabilities depending on the altitudes that the science teams are requesting or the total suspended mass of their instrument. We'll try to find something that's going to be an optimal fit. I mentioned a little bit about the altitudes that we're flying at. So we are well above commercial aircraft, right? So above 99.9% of the atmosphere. We're usually hovering just above the ozone layer, but we're still significantly lower in altitude than the space station, CubeSats, even sounding rockets, which is what really limits our ability to do microgravity type experiments. So in the launch video that I'm going to play, you're going to see some of these components, but I wanted to point them out here first so you can get, again, a sense of scale. So you've got a semi-truck over there by that little bubble. That's the semi-truck is filled with helium. It usually takes 1 to 2 trucks per balloon. And then you do have a little person standing there by the truck holding on to the inflation tube. And then that's only like 8 to 10% of the balloon that you see inflated there. And the rest of the balloon is actually laid out on the ground until you get all the way to the parachute and then all the way to that payload. And this particular payload is the size of a small SUV. So this launch video I'm going to show you, this is a launch from Sweden. So it takes about 3 or 4 hours just to get out to the launch site. So we have to do last minute comms checks on the payload. We have to do a lot of last minute connections from the top of the balloon all the way down the balloon, all the way down the parachute to the gondola. The balloon is laid out by hand onto the ground. They also lay ground cloths on down on the ground to protect the balloon from anything like rocks, brush, whatever. And then inflation takes about 30 minutes, give or take. And then nice and slow, gentle release. And then you're going to see that crane drive around, trying to, the crane will drive around and try to release the balloon when it's as perpendicular to the ground as possible so we can avoid any kind of pendulum motion with the gondola. So generally, slow and quiet and boring is a good launch. So the absolute opposite of a rocket launch. We rise up about 1,000 feet per minute. So this particular balloon's going to 120,000 feet. It's going to take about 2 hours to get to our float altitude, to get to our full shape. It's a super pressure balloon that you're seeing there. And then great views, and we're going to fly around from 8 hours to 50-something days, as long as possible, really. And then we terminate the flight when either the science requirements are met or we're starting to get to a place where recovery is going to be difficult. So we do kind of prioritize recovering all the materials. So we separate that payload and the parachute, and those 2 items will come down nice and gently. The balloon will rupture and come down separately, terminal velocity, because we don't need to protect that at all. We just go and recover it. Usually they come down a couple miles away from each other, so recovery is not too difficult. And a reasonably gentle landing. Yeah, there we go. All right, so mostly we're at the mercy of the stratospheric winds. This is very similar to you guys, right? So you've got to set up in places where you know where the stratospheric winds are heading. Your pattern is relatively stable, and you can rely on that for trajectory planning. So we love, in particular, going to Antarctica for Antarctic summer because those strat winds will set up in almost a perfect circle around the continent. It's been really great for us. We've got a balloon that's still up flying right now. It's been up for several weeks. And we hope to be able to recover things as close to where we launched them as possible. It makes it a lot easier to recover. So we'll go to Sweden in Arctic summer. We're going to be there this year, starting in May. And then we'll fly most of our flights actually out of Fort Sumner, New Mexico in the fall. And in the fall there, we were actually hoping to get some turnaround flights. And what that means is that you'll get these polar vortex come across, bringing the colder weather, bringing storms, but it actually, the stratospheric winds with that polar vortex do a 180. So we will fly towards California for several hours, hit that turnaround and come back. They're a little bit harder to predict, but they are a great phenomena of both like a fall and springtime atmospheres, and one we really rely on. So I mentioned some of the locations that we're going, and you'll see what they have in common is that they're all very remote. So we generally have to bring our own equipment, sometimes our own buildings. We're hoping for, really low populations just to increase safety should something happen. With a balloon that's got 20 something acres of plastic in it, you generally want to keep that away from big populations. And that applies for the whole flight trajectory too. So that's also why we're trying to do the Arctic or the Antarctic, or staying out over the desert. All of our student launches will happen in Fort Sumner too, because we want to make sure the students are able to actually attend the launch. Same goes for Palestine, Texas. So I didn't mention, above 99.9% of the atmosphere, but just one other, I guess, plug for why the stratosphere is such a good place for these observations. The graph that you're seeing here is, the transmission of different radiation based on their wavelength and based on the altitude of the receiver. So even with a telescope on Mauna Kea, which is above the clouds, if you've seen pictures of it, it's extremely tall. Well, I think it's a volcano actually, and that observatory is perched on, but it still does not get good transmission, especially in like the visible light range or the UV range. So depending on what science you're looking at, the balloon gondola is really the only place where you're going to get quality data. So most of what we do is indeed astrophysics. We do some earth science and some heliophysics, but the lines are actually really blurred between the two because a lot of the earth science we end up doing is really how the sun affects the earth. And then just for fun, so you can see our gondolas really come in all shapes and sizes. The only rule we give to the science teams is that they need to be able to fit out of the bay door at the launch site. Even then, they try to stretch that by adding things once we've already gotten outside. So I'm going to tell you about one particular flight here. So this is the Superbit flight from New Zealand this past spring. So it launched in April 23. And we almost made it around 6 times. So we made it around the Earth 5.5 times and just captured some phenomenal data. It was a great test flight of our super pressure balloon. We were able to see the southern lights over the top of the balloon. And it was an optical telescope or a visible light telescope, which we don't get very many of. And the reason why we like them is because they return pictures like this, which is just incredible, right? So the Superbit telescope is a larger field of view than James Webb or Hubble, and they're looking at some of the same targets. So it's really just impressive to see what they can do from a balloon platform. All right. Last thing I'm going to tell you guys about is some of our student opportunities. So Cubes in Space is really designed for younger students. So these are middle schoolers and high schoolers. You get this, like, I think it's like a 2-inch cube that you can put basically whatever you want in it. With the balloon platform, you can even attach multiple cubes together and have powered experiments. There are always there's always extra space available. So I would encourage you to check it out, even if you're not sure what you would want to do, because there's so much opportunity there. If you know anybody that falls in this age range, you should recommend them too. It doesn't have to be a school group. It can be, as long as there's an adult to sponsor the kids, it can be any group of interested kids that you can come up with. And there's curriculum package. There's a lot of great resources. So go check it out, Cubes in Space. And then we've got HASP. So HASP is our university level dedicated balloon flight. So you get a little bit stricter requirements on your size, your mass, your power and telemetry availability. But like Cubes in Space, there seems to always be extra room. So we can fly up to 12 payloads. And this last year we got about 11 applicants. So we would encourage you guys to check it out and apply, even if you're not 100% ready, because even the feedback you would get from a proposal is better than none. And maybe even that feedback is like, hey, you tweak 1 or 2 things and you'd be ready to fly, and we're ready to fly you. So it's worth trying. It's worth checking it out. And I think a lot of the work that the student groups have been doing for NEBP, at least from the things that I have heard, could lend themselves to a HASP flight. You can use the same types of payloads. You could expand upon them. You can look for different sensors. You can continue doing those hand launch flights, because you get great data, especially now with the valves that several groups have employed to get longer flights. Those hand launch balloons are great, but if you wanted to try something with a much longer flight, try some more complicated electronics, I think HASP would be a great way to go. And you guys I really encourage you guys to go check it out. The last but not least is internships, right? So we have several interns down at CSBF in Texas, several at Wallops. We hire them all year round. And it's a great way to get your foot in the door with NASA, even if you don't come work with us, but you're interested in NASA, just period. All of the NASA facilities and even all the satellite facilities have internships. And it's a one-stop shop. You go to intern.nasa.gov. You can create a profile. You can sign up for, 1-click, 2-click applications once you set up your profile. So I encourage everybody to go check that out. All right. And I'll leave you with an actual legitimate shot of a zero pressure balloon against the moon. So that's not photoshopped. And I welcome your questions.
Awesome. Thank you. I know that a few people had submitted questions ahead of time, and Julia will read those in just a second. Could you tell us one more time the website for the internship? That seems to be when we ask our students what they're most interested in. It's always about internships with NASA. And then maybe somebody might have asked this question already, but if you have any advice for people as they're creating their application or anything like that, I have a feeling that people will be quite interested in hearing more about that.
So I'll tell you a couple things. So I'm going to put these links in the chat. So intern.nasa.gov, that's the main thing. And then I'm going to put the HASP and the Cubes in Space in there too. I will say that I've read applications for HASP, and I've seen a couple of things in common where some groups don't take enough time to proofread. And it's even like silly things like they've numbered their paragraphs and they, have 2 number 4s or something like that. Like that's a silly one, right? But what it says to us, let's say there's 20 applicants and we really got to narrow it down. Well, it says to us that your attention to detail isn't a high priority for you. And generally that means that you won't be as successful with your experiment as others. And so we would put you down the rung. So taking the time to proofread is a really important thing. I have done all the intern hiring for the last several years, and I will say that's another really common trend with the internship applications, that we'll get 150 applications for the summer, and you have to weed those down somehow. The easiest way to do it is to start by just downloading a big Excel file that's got all the fields. And if you didn't bother to put something in each field, even if it's not applicable, I just throw it out, because I have to have a way to weed something out, right? So if you can't take the time to fill out each field, okay. If you can't take the time to capitalize your name, because I've seen that, I'm gonna throw that out. And those are things that have absolutely nothing to do with your technical skills or what engineering classes you've taken or what your GPA is, right? We've had students that aren't from engineering backgrounds do really, really well because they've got good attention to detail, and because your ability to learn and your those other skills, those like lab skills even, are sometimes more important than your GPA or the field of study that you're in.
Awesome. That is excellent advice. And as a person who has hired a lot of students, I absolutely agree with you. If you are sloppy on an application, you might be sloppy in your work as well. So thanks for that advice for everybody, and a good reminder. If anybody has questions, you can definitely unmute or raise your hand or use the chat. If we don't see any right away, I think Julia has a couple that were submitted ahead of time. And then meanwhile, we'll kind of watch the chat here or watch for people's hands and see if anything comes in.
The first one I kind of wanted to mention, and I know, Sarah, you touched on this already, but if there are some student-led ballooning teams that are interested in gaining knowledge or being a part of opportunities from NASA, are they able to get in touch with you directly?
Yeah, 100%. I'll put my email in here as well. Yeah, if you've got questions about follow-on opportunities, if you've got questions about HASP, if you've got questions about even just continuing your hand launch type work, please, we'd be happy to talk to your groups about it.
There was another question. I'd like to learn a little bit more about the BPO educational outreach, and if there are ways for institutions to be involved if they aren't in the same geographic area. Also, does the BPO conduct any technical hands-on work for their programs besides a more managerial role?
Yeah, so I did mention that, right, that at Wallops, it's mostly management and technology development. So I guess I didn't really touch on that at all, but we have, engineering resources at Wallops, and most of even our technical managers all have engineering backgrounds as well. And we're doing things like we're working on a completely new avionics package for our balloon systems that'll be more plug and play. It'll be more modern, and hopefully, people keep using the phrase future proof. Hopefully it'll be easier to swap out components when they become obsolete. But technology moves so quickly, we'll see what happens. We're working on new telemetry, things like optical communications, moving away from the RF, trying to get data down quicker in larger bursts. We've even looked at physical data drops, right? So that's like physically dropping a hard drive from the balloon in flight and then going to recover it. We're actually working on switching to hydrogen just because of the cost of helium. And so this is going to be a really big project for us. It's going to take a lot of changes to our operations and some of our equipment. So we're really doing our due diligence there with our research. It's going to be a really long, slow project. We are always looking at materials, making our materials better and making sure that they can last through the really long duration flights. That's 50 plus days of high intensity, UV radiation. And if any of you are chemistry people, we basically are flying, and everything with carbon-carbon bonds in the regime where, you know, the radiation is specifically targeting carbon-carbon bonds. And then anytime we touch that top of the ozone layer there, we've got all these free radical oxygens, which just love to attack. So we're always looking at our materials and how to make them better. Let's see here. Telemetry, lightweighting. We're getting really into carbon frame, like carbon fiber frames for stuff. But the material properties aren't really easy to find. So you can't do modeling. You got to do a lot of actual testing of the carbon fiber pieces. So we've been getting into that. We've actually been getting into a lot of 3D printing and even of, you know, using like plastics, but we've got a metal printer now too. So we're started doing some metal printing. I don't know. If people have more technical questions, I could dig into all kinds of other stuff. But the other question was educational outreach. It really depends on what you're trying to do. So I would say if that was a specific request, to just send me an email. We do go visit local schools, and we'll go work with. Have worked with a local school to do a HASP experiment before. But it really just depends on, I guess, what your specific request is.
I did get a message in the chat with another question. Do you happen to have an example on how this would work for ocean weather people? For example, Pineapple Express references currently in the news.
I don't actually have any idea what that is. I thought the Pineapple Express was not something science related. Whoever put that in the chat, maybe you can speak up and tell me about it, and we'll see what we can do.
Hi, Sarah, this is Omar. I'm curious to know, like, how would this, right now there's a reference that there's a Pineapple Express on reference to like atmospheric rivers. And so do you have like an example of like how they do this on, you were using a lot of examples of like land for the balloons. Like, do they do this in the Southern Pacific Islands? Like Hawaii most likely has a weather station. Like,
Yeah,
so that
NOAA launches weather sondes. Those are the smaller latex balloons all over the world, actually, not just the United States. And there's a couple of websites where you could go pull sounding files. I think Wyoming Weather Web is one of them, where they've just got this huge database of sounding files for different weather balloons. And that basically all the way up, like every X meters, they'll give you a line of data on ambient conditions. We don't do very much atmospheric research because we fly in the same couple of places all the time. And we're really kind of marketing ourselves more towards astrophysics, you know, because you can get that kind of information, that atmospheric data, from a 10-pound payload, and we're flying 8,000 pounds, right? So kind of, yeah, it's just a different, I guess, customer base. Oh, Marissa putting me on blast. Okay. In 2010, in Australia, we had an issue where the payload, so we had a wind shift. So, you know, you got that little bubble, you release the bubble, and then now we're driving around trying to get the payload right underneath the balloon so that it can be released without a lot of swinging, right? Well, the wind shifted and was heading away from the crane faster than is normal. And we were driving as fast as we could, but we reached the end of the airport, like the fence, like we could not go any farther. And the payload actually broke away from the crane and then took out an SUV. So you can actually YouTube it if you want to watch it. It's sad. But No one was hurt. Thankfully, it was just, instruments and pride. But what we did was we set up much more extensive roadblocks and launch safety areas. And we changed the way we kind of lay out the balloon and payload based on the wind direction to make sure that there is enough room to drive should we need to drive. And if the winds are higher than a certain set threshold, we're just not going to launch at all. So it really kind of just made us a little bit more risk adverse. So some would argue that's a bad thing because we're not launching at the tempo that we used to, but we would rather be safe and not cause any damage. It's sort of like all of NASA is that way too, right? You see some of the stuff that SpaceX does and you think, why can't NASA do that? It's like, well, we're not willing to take the kinds of risks that they are. Yeah.
Sarah, I have kind of a follow-on question to that. And again, I encourage students to put, or anybody here to put any questions in the chat. I think a lot of our students are interested in, it's a pretty pressure situation when you've been training and working and practicing and suddenly it's like launch time. Maybe people are emotional, maybe things aren't going 100% the way you thought they would. Do you have any advice for people on just kind of keeping calm or supporting your team or resolving any conflicts that come up?
I am a very hot-blooded person, so I get it. I really get it. I wish I had some sort of magic wand for you, but I don't. But it's the exact same advice I think that I would give people in your daily life is that it's worth just giving everybody a little bit more grace. It's everything can be challenging anymore. And you'll find this, I guess, the older you get, that life seems to get more complicated instead of less complicated. And you just have to, sometimes you just have to let it go. It sucks. If you got all the way, you did all this work, April 8th, you get there, you go to launch and find out that your helium tanks were accidentally half filled with nitrogen, that would suck. We've seen that happen. Go to release a payload and it comes right back down. There's not a whole lot you could do about it. But everything that you did to build up to that day of launch is an amazing learning experience. And learning that process is so important. So I still think that you've got something great to take away from the experience, even if you didn't get to actually fly or if it didn't fly perfectly. But in ballooning, a off nominal flight is almost like as normal as a normal flight. So I think, recover from it and try to launch again. Those instruments, so what, you don't capture the eclipse, you launch the next day, you're still going to capture some interesting atmospheric data. So.
Great, thank you. Julia, do we have any others that have come in, or if anybody wants to unmute or type in the chat, that'd be great.
I do have some more from the Google form. Sarah, you kind of touched on this with some of your earlier answers, but we had 3 people ask what your most challenging part of the project was, one in specific to the CubeSat project. Yeah, just in ballooning. And then expanding on that, your most interesting project, as well as your favorite subject in engineering.
Yeah, I really liked thermo. Even though it was like the hardest, I just liked the way everything balanced out. I liked the math. That's why I hate biology, because the math doesn't make sense in biology. You got 5 petri dishes and 2 of them grow, 1 of them doesn't, 2 of them grow something else. Doesn't make sense to me. The CubeSat stuff, I guess I'm not really, we don't do very much with the actual cubes. We just fly them. and then return them. Technology-wise, I mean, I'm working a bunch of different projects. That new avionics package is something that I'm managing, and it's been very interesting doing the trade studies on all the available new hardware that's out there, and really using the math to inform us on what the best product is. So it's not just like you read a data sheet and you say, this is great. No, you read 15 data sheets and you put them all together and figure out which one's actually the best. I like doing that kind of stuff a lot. The hydrogen work's been interesting because we're really digging into the history, and we've created an international cohort of balloon launch providers that are all working this challenge together. And so that has been fascinating to work together with a really interesting and diverse group of people. But that one is challenging because it's moving so slowly. I would much rather get after it and start doing the actual work. But because it's such a big group, and because we have to, be so safety first, we have to have all of this background data that, is proving that our test plan is sound and safe. And so that's frustrating to me, but I understand the reason. And then I've been doing a lot of materials research, and that I love because it's fun to break things on purpose. And then I love getting all of that data together and running the statistics and trying to discover something in there. But that can be super frustrating when you put it all together just to find out that there is absolutely no statistical significance in any of your data, which is almost worse than the data saying that you were wrong. It's your data saying you have nothing. But that's research. That's how it goes sometimes. Yeah.
I had a quick question.
Yeah, go ahead.
Yes, I'm on an atmospheric sciences team out here in Montana with NEBP at our tribal college. But I was just thinking, I have a lot of fun with our launches, and it seems like it would be especially a lot of fun doing a launch with such a heavy payload. And it sounds like there's just all kind of variants, whether it gets to be up there for a number of hours or days, and you get to travel all over the place, go to remote locations. I was just curious, are there any internship opportunities for working on the ground, hands-on?
Yeah, there are 5 of them open right now for this summer at CSBF in Texas.
Oh, okay.
Yeah.
Very cool. Also, I love your pictures.
Thank you. Thank you. Yeah, that's the coolest part about the remote locations, right? Like the group in Antarctica actually encountered some seals this year. So that was pretty cool to see pictures of seals in the wild. The reindeer can actually be a little bit of a pain in the ass in Sweden, but they're cute. So I like to take a picture of them too. But they poop everywhere. And they really don't care either. Like they'll just stand there and look at you like, I'm sorry, you're on my land. Anybody having a technical challenge with their balloon they want to talk about? Not even questions about that.
So maybe while we wait to see if there's any questions there, I think we got all the ones that came in originally. I don't see any in the chat. You have an intriguing background, starting in music education and then moving into engineering and onto NASA. It's kind of the classic STEM in the arts. I wonder if you could talk just a little bit about how your background in the arts and education coupled with your STEM experience. Because I think we have some other people who are in that same boat, or maybe thinking, I can't go on to work for NASA because I'm a arts major. talk to us a little bit about how that package works for you.
Yeah, so it is, I'll say straight up, it's not easy to get in with the federal government anywhere. But the easiest way to do it is through internships, through a pathways internship. So you can go to intern.nasa.gov. That'll help you get started. But they'll even direct you from there to USA Jobs, which is where you'll have to actually apply on that other site. And if you've got specific questions about that, again, you can email me. We could have a whole another session on how to do that, applying. Going back to school and being significantly older than everybody else, I think was actually helpful, because I was not even remotely embarrassed about going to tutoring or office hours. And there were classes where I was at every single office hour. I probably annoyed the shit out of that professor, but for a class that half the class usually fails, I got an A. And that is like one of my proudest moments, because it was hard. I mean, that's why I was in every office hour. It was hard. It was really hard. And I also, wasn't afraid to ask questions, and maybe, I don't want to ask that question because I might look stupid. Well, it turns out everybody in the class was glad I asked the question, because nobody knew what the hell was going on. So I would take that just from being a little bit older. That helped me. The teaching thing has helped, because you have to be able to speak about what you're doing to get the money in order to keep doing what you're doing. If you want to do research, you have to be able to apply for grants. And so a lot of that can be written, yes, but sometimes you actually have to go talk about it, and you have to be able to distill it to a manager or a politician, and get them to understand why what you're doing is important. And that's why sometimes the other classes like the arts and some of the psychology that you had to do for teaching can help, because you kind of understand people a little bit. I think it's made me a better manager. Although sometimes also life lessons can make you a better manager, just knowing what's important and what's not. And truly, it's like, work is work. Even if you're really passionate about work, it's still just work. I don't know. It's not the cleanest answer, but.
Well, you got some applause there. I don't know if you could see it, but several people were applauding the office hours and asking the questions and everything. It sure is important. And I did want to make sure that people saw, Marissa had put in the chat that students should also reach out to their state's Space Grant Consortium, who usually has funding to sponsor students in NASA internships.
Yes,
so
yes.
Definitely put that on your radar. All right, well, we'll wait maybe just one more moment here, see if people have questions. We will have a feedback form for everybody, which we'll post in just a second. This actually helps us more for our future presentations. It's an opportunity for you to suggest any people you'd like us to reach out to, and just help us know what we can do over the next couple of months to make the speaker series even better. So any last questions? Oh, I see a good one here. Actually, this seems very appropriate. Can you see that one, Sarah?
Yeah, it's incredibly frustrating. I personally don't like being the person that lets other people down, right? Like, I take pride in my work. I like my work. I take pride in my work. I don't want to do a bad job. And so I hate the fact that everybody has to be understanding. But what am I going to do? She can't go to daycare. I also, until today, have felt like garbage. And so even though there are deadlines, you have to take care of yourself. And she's been in a lot of meetings and has met a lot of people. And sometimes I have to leave a meeting 10 minutes in because there's a total meltdown. You just got to do what you got to do. It is not, listen, it is messy, sometimes literally. And I think everybody, like the whole society, is starting to get more understanding about how tough it can be, and the more we just push on the people that aren't understanding, I think the better that we're all getting, the more that we just support each other on what's actually important. What's a deadline anyway? Like, we're not doing crewed space flight. We're not doing anything of like security or anything like that. It's no one's going to be injured or die or suffer because we launched a day late. Now, I can see some people getting really upset if we skipped an entire year, like if we missed a whole launch season, because then funding cycles, because you only have sometimes 3 years for your funding. But that's also why we can do like these little funding extensions. You know, it's possible to ask for the help. And that, maybe that's the other thing with age, is just ask. You're not going to get 100% of the things you don't ask for, or whatever that phrase is, right? Yeah, mommy's working. Yeah, we're almost done.
Children?
You're the only
I love it.
children.
Well, I feel like we should allow you to be done. We sure appreciate you. You got a lot of comments during that last answer too. People appreciate your perspective on the work-life balance, and you're obviously living it in real time too. So thanks so much for being with us here on the speaker series. Julia has put a link to our speaker series feedback form in the chat. We hope everybody here will be back with us again next week. Julia, do you have the date and time for next week's speaker in front of you? I mean, if not, that's okay. But if you do, we'll announce it.
Yes, it'll be Friday, February 9th from 2 to 3 p.m. Pacific Standard Time with Dr. Michael Kirk from NASA Goddard Space Flight Center. And we'll be updating our website with the registration today.
Right here. Right here.
All right.
No
Well,
view.
Dr. Roth and family, thank you so much for being with us today. Thank you, everybody, for being part of the team. We appreciate everything you do in the ballooning world, and especially for being here with all your great questions today.
It was my pleasure. I had fun.
Are you okay, Mommy?
All right. Thanks, everybody.
Yeah, we're saying goodbye to everybody. You say bye-bye?
Bye.
Bye-bye.
Bye-bye.
Bye-bye.